Hello everyone, I'm Joel Ifill, the tube dude, welding engineer who nowadays mostly focuses in aerospace, nuclear, and of course orbital tube welding, and I wanted to hand it over to you, Logan.
Thanks, Joel. I'm Logan of Kucerak Engineering, the sole owner. I focus on supporting my customers with qualifying procedures and all kinds of code systems and their vendor surveillance, expediting processes, whatever the customer needs in order to get that good weld.
And today we're going to talk about welding codes here. You know, as welding engineers, I think we can have a much more nuanced conversation than most. But I think, as you know, a lot of times our work is just helping people out. You know, what are the codes? How do you use them?
Yeah, and that's, I mean, Joel calls himself a tube dude. I'd call myself a code guy. That's really kind of where my expertise shines, and navigating all of these different codes and understanding how those ecosystems work and what you've got to do to meet each one of those.
Right on, right on. So with that, I think just to set the ground rules, we're going to cover some of the most common welding codes you and I have seen out in industry. What are the strengths? What are the weaknesses? Why would you use one or the other? I think we both have some favorites going into this, and I think we have some good conversation around that. Yeah. But at the end of the day, we all know which one's the best code.
Yeah, ASME.
No, it's 17.1, man.
Oh, come on. 17, nah, not even close.
Yes, well, we can talk about it.
All right,
you know?
all right.
It's okay to be wrong. So with that, I think we'll just go down through the codes here, starting with D1.1. I'll let you explain it.
So D1.1 is going to be probably the most commonly used code. It's used for structural fabrications across the entire U.S. Okay, this is going to be found in the CFR, the Code of Federal Regulations. So it's going to be mandated by law in a lot of places, and it's going to be all your structures. So any of your high-rise buildings, any of your space frame supports, any large steel structure is going to be governed by D1.1. And it's only going to deal with carbon manganese steels, and we're going to be limited to mainly your GMAW, FCAW, SMAW, SAW type welding. Okay, this is heavy fab, think girders and space frames.
Yeah, and I'll add in, sometimes it's called the welding Bible because it's huge. It's thick. It's been around for decades here. It's kind of the standard. I think a lot of codes get compared to it because it's kind of the standard, the most common one in the most common industries, which is...
Yeah, and that's the main choice when you go to like take your CWI is usually like 1104 D1.1. And a lot of people go, well, don't do D1.1 because it's really thick. I don't necessarily agree with that because you should take the CWI to the code that you're used to, and the fact that 1104 doesn't have an index. So if you're trying to go through and answer those questions in a timed manner and don't know where all those things are located, it doesn't matter that there's less pages, you still got to find what you're looking for. Yeah. The nice part with D1.1 is that it's set up in a pretty nice little methodology, you know, going from design to qualification, fabrication, inspection, and you know, it builds on those basic concept of how we design things to the full product.
And so jumping into D1.1, 1.1 further, what are some of the applications you would recommend for D1.1, and what are some of the ones you would say, hey, this is not the right code?
Well, D1.1 is mainly supposed to deal with steel that's thicker than like 3/16 of an inch and above, and it is all carbon steels, right? So any kind of piping in a power plant would not be good for D1.1. This is not going to have, you've got a section for D1.1 that's for tubular section, but when we talk about tubulars inside D1.1, they aren't to carry product, it's to hold a stress. So the biggest thing you can think about D1.1 is that we're worried about holding a stress, okay? How we support that stress and how it's transferred through those members. Okay, it's not about transferring fluids like some of our other codes and standards. The key here is that what we're trying to be sure is that the buildings that we're in are meeting our strength requirements, that we can put, you know, 600 pounds per square feet on this mezzanine and it's not going to fail, right? Those are the types of things that we're concerned with inside D1.1. We're not worried about holding pressure. We're not worried about corrosion from flow of whatever fluid. We are mainly just trying to support some sort of stress.
Copy that, copy that. And one of the things I often recommend, hey, most people, you're probably welding steel. It's the most common metal by tonnage, by a large margin. It has a lot of pre-approved joints in there, joint designs. If you're just doing work around the shop, etc., it's not life critical. But you want to learn more, I'd say look in D1.1. There's probably already an example of what a good joint looks like, what a good fit up looks like. It's a great starting place, looking at all your kind of basic joints here, all your basic principles in sound welding and sound welding engineering.
Well, part of what you bring up there is the pre-qualification, where is that you don't have to run a PQR, you don't have to spend a couple $1,000s to having a weld made and having tested. Is that the code says, hey, if it is this joint design and it's this process and it is these parameters, is that's been made enough times in the industry that you're more than welcome to make this on your own, and you don't have to run a PQR to prove that it's okay.
Yeah.
The other thing about D1.1 is if you want to learn more, they do have, a third of D1.1 is just in the back of the code where it explains the clauses, where it explains where a lot of these things come from and what they're trying to prevent. So if you flip towards the back, you can find out where a lot of the lineage of this information comes from. Yeah. So it's not as big of a secret as what we see like in ASME, where they just changed something and
you don't know why.
You don't know why.
Yeah. Right. And just to explain it here, PQR, procedure qualification record. In welding, it's always a prove it industry. You're welding new materials together. The thing is, prove it, show that it has the strength, show that it meets the requirements you want to use it for. And you do that through a procedure qualification record. The good thing about metals is their properties don't change over time. Steel, there's very common grades that have been used in industry for decades now, near centuries. So there's already pre-qualified procedures, records of, hey, here's your A36 steel, your very standard steel. Here's how you're going to weld it together. You don't need to kind of go rewrite the book every time you do that.
Yeah, and that's the point, right? Is if we've got groupings of steels as well. If we had to run procedures on every single individual steel, you wouldn't build anything. All you'd be doing is running procedures because there's so many different types of steels.
Yeah, and so a lot of the codes do that. They'll group different types of steels and metals together, saying, hey, these weld similar or the results can be similar. So you don't need to kind of differentiate further.
Yeah.
But you get into more rare things. There's just millions of possible metal combinations. You can't kind of pre-write down, hey, how do I weld this to that?
Yeah.
In this thickness and this configuration. It's just going to be too much. So that's where you go and you do a PQR. You go basically qualify that this will make a sound weld.
Yeah, absolutely.
So, and flipping around, what are the downsides of D1.1? What don't you like about it?
Well, what don't I like? Well,
where to start?
We don't have the first thing, and I do understand where this clause comes from that I take, is that running a PQR inside D1.1, it's what we refer to as kind of a positional issue, where in order to make a weld in production that is either vertical or overhead, you're going to have to run a plate of that is for that PQR in that vertical or overhead position. So the position is an essential variable in D1.1. And so part of that is tied to the amps and voltage ranges that are limited inside D1.1. Because obviously the flat weld that you're going to make is not going to have the same parameters as the vertical up weld you make. But it doesn't necessarily, at least in my view, prove that the material combination in filler metal is going to give you a sound weld because you do it overhead. That's got less to do with that material filler metal amperage and voltage combination than it does with the welder skill. And you're already going to do a welder qualification test with that. Yeah. Right? So understanding the applicability of what you do in D1.1, everything that you do isn't going to be pre-qualified. You still have the possibility of having a qualifier procedure inside D1.1. The other thing I don't like in D1.1 is that something that is kind of different, especially across the other codes, is that the only inspection that's required in D1.1 is 100% visual. Okay, 100% of the weld is supposed to be visually inspected, shall be inspected. Now, D1.1 gives you acceptance criteria for MT, UT, and RT, but it doesn't invoke that at all. Okay, so sometimes there's a lot of confusion from design engineers who they're used to dealing with another code where they can increase the quantity of radiography that they do and get a better quality factor in their design allowable calculation, and that doesn't exist in D1.1. Okay, so the other part too is having that acceptance criteria in there. It's really good for somebody who's trying to start getting into that, but it's also like the design engineers who aren't really familiar with D1.1 go, well, here's the acceptance criteria. I assume that they're doing some percentage.
Yeah.
Whereas it's not really the case.
Copy that.
Okay. The other thing too is when we do a PQR inside D1.1 is that, as I mentioned, they don't invoke any radiography or volumetric inspection, but your PQR has to pass radiography and tensils and bends and any additional tests that your client has.
Yeah.
But none of the welds in production have to be subject to that.
Yeah.
So it seems like a higher barrier for the PQR than it does for production.
Yeah.
And that's not, we'll see, as our discussion goes on, we'll see that kind of flips a little, but that's a little bit of a difference that people don't quite grasp.
And I say over in the aerospace world, we always consider D1.1 a lower quality code because it doesn't require the volumetric inspection. Yeah. It doesn't require other non-destructive testing processes. And just to go over for the audience, so you have volumetric inspection, which is some way of seeing inside the volume of a weld. Visual inspection, you only see the surface. So he mentioned MT, which is mag particle inspection, UT, which is ultrasonic testing, and RT, which is radiographic testing or X-rays. And those ones can give you better volumetric information on your weld here. Do you have a crack, but it's just subsurface? You're not going to see that visually, but you can pick that up often on UT or X-ray.
Yeah, then the question becomes, I've worked on a couple structures, especially in the offshore industry, where the node sections that are connecting legs of an oil rig get 200% UT, where company A has to UT it and it has to pass, and company B has to UT it. And if they don't agree, then they go back and fix something.
Yeah.
Okay, so it really kind of depends. And a lot of conversations I've had with design engineers is like, well, can I do more radiography and I get better allowables? Not really, not in D1.1. It's kind of big, dumb, and heavy, and that's the way it is.
Yeah,
right?
Yeah. I'd say it's kind of lowest common denominator. It's kind of bad to say that, but it's like lowest common denominator.
Yeah.
Hey, this is good enough to put up a building, a 5-story a building here, a little tiny indication or pour is not going to be an issue, but you're talking about a fracture critical girder on a bridge where if this weld fails, the whole bridge collapses. You want a little bit more nuance.
Exactly.
Yeah. On my downsides for D1.1, it is so large. I find for new people, if you don't have the guidance or the experience as a welding engineer, it can be a little intimidating. Opening up this 1,000+ page book and trying to figure out, hey, I just want to understand what's my inspection criteria for a really simple butt weld or whatnot. It can take a little while just to sift through it, and it's easy to kind of get lost in the code if you don't know what you're looking for. But overall, I do recommend it as like it is kind of the basic or the standard, which most others are compared to. It's kind of the default code if no one else is going to mention anything else. Well, then probably look in D1.1 because, again, you're probably welding steel. And if you're not...
Well, you're only welding steel.
Yeah.
So.
And I say, you generically, like most people are probably welding steel because it's 80-90% of all metal by volume and by tonnage is steel. So... if you're welding something else, you probably know that, hey, if I'm welding stainless steel, I'm doing it for corrosion resistance. Okay, what do I need for corrosion resistance? Yeah. And with that, let's go on to the next code, and I'll have it back over to you, which is D1.
D1.2 is going to be structural steel for aluminum. So we see this pretty heavily in tooling for the aerospace industry. We also see this a lot for marine fabrication. So we're going to use aluminum as a structural material. Most of the time, aluminum has a lot lower tensile strength than steel does, and we're going to use it for its strength-to-weight ratio, its corrosion resistance, something of that nature. The hard part with D1.2 is that its biggest downfall is that it doesn't allow pre-qualified procedures. So it doesn't matter if it's 6061 using ER 4043 with 100% argon in a single V, you've got to run a procedure. Okay, there's no such thing as pre-qualification. Okay, so you're going to have to run a procedure. It's going to have to pass the tensils and the bends. And that is costly, time consuming, and aluminum is always a little bit tricky when we get to bending and tensils, especially with a fusion weld where those tensile strengths drop dramatically due to the heat effect zone problems. Yeah. So most of the time I've seen this, like I said, marine structures where you're building a dock for the military, or a structure that's going to support a part of a rocket that's sitting in the factory somewhere, something like that. Yeah. It is again, that's a code, so that is going to be a legal requirement that's potentially invoked. It's going to cover all your standard aluminum alloys, right? And it'll have your minimum tensils for all that in there. So it's one that's not used as frequently, just because the lion's share of aluminum fabrication is not for structures. It's just been brought up a bunch of times in my career where we're building something kind of unique, and the customers require this because it's going somewhere that
it does actually matter.
It does actually matter. Yeah. So usually the barrier to enter in D1.2 is a little bit higher, because you're always going to have to run a procedure qualification record. You're going to have to qualify welders. And that's just cost and time. And
let's be honest, welding aluminum is usually a bit more involved and difficult than welding structural steel anyways. Yeah. Which scares a lot of people, and it's more expensive, so it scares a lot of people away from fabricating with it. Yeah. Aluminum's used all the time in aerospace industry because of its lightweight, but we don't use D1.2, we use D17.1, which we'll talk about later. So when I think of high quality aluminum welding, I don't think of 1.2. Man, I sound so negative here. Maybe because the aerospace guys always like, we're doing the highest quality stuff.
There's definitely, as someone who's worked in the aerospace industry, there's definitely an overwhelming air of superiority with 17.1. And I get a little bit of the product line, but when we get to 17.1, we'll see that I think it's got some flaws that could be improved upon.
And some strengths. It's got some strengths too. There's a reason we use it. All right. Anything else we should mention about D1.2?
No, just the main one is, there's no pre-qualification. So calling that out in a contract or some sort of legal document, you better be looking for PQR WPS. And
there you go.
That's if you've been work that is that, quote unquote high speed, you should be doing that anyways. But I've seen a lot of times in my career where we tap this aluminum shop and all they do is aluminum, and they sign the contract and I ask them for these documents and they don't have them, and they go, what are you talking about? All we do is aluminum. It's like,
still need it.
That's fine, but that's not the contract we signed. So
I think we both in our career been like, hey, you've been doing it wrong for 10 plus years. Like, sorry to be the one that has to say it, but oh boy, we're gonna have to dig into this now. The only time I've ever recommended D1.2 is, I say for the general public here, people starting to get into aluminum fabrication, motorcycles, bicycles, something like that, and they want to know, hey, what makes a good weld? I'd say go look at 1.2. It's going to give you more of that definition and detail specific to aluminum welding. If it's good enough for a bridge or a boat, probably good enough for your bicycle too. But always be careful if you're welding, I say life critical things, if the swing arm on your motorcycle falls off on the highway, that's probably a really bad day.
That's a real bad day.
If you don't know, if you think you can somehow skirt all the codes, I don't need to do the code work. Just reevaluate your life decisions. Even as a welding engineer, some of that stuff, it's like, I'm not going to weld on it because I know what it takes, and I don't want to try to have to meet all those. I know myself. Yeah. I'd rather not do the work at all or send it to a shop that is qualified for it.
Absolutely.
Yeah. And going on to the next code, we have D1.6.
D1.6. This is structural stainless. So if we've got to build some sort of structure that is out of stainless steel, completely out of stainless steel, we're going to look at D1.6. A lot of D1.6 work that I've done in my career is I worked at a nuclear facility, and we were building these space frames that were going to be pipe supports that were in a quote-unquote hot area that once it was sealed, nobody was ever going to go back in there. Yeah. So we had to be sure that any atmospheric corrosion. The items weren't exposed to radiological material, but they were going to be in an area that we could never get back into. So we didn't want the structure to fall from corrosion after 10,000 years.
Yeah.
That they're all made out of stainless steel,
Yeah.
just to be sure that any atmospheric corrosion was taken care of. And D1.6 is going to have prequalification in it because using GMAW and FCAW and SMAW on stainless steels is nothing new. We also see that if we've got a D1.1 structure and we've got some sort of stainless clips, some sort of stainless attachments, your dissimilar metal weld, your DMW, is probably going to be run in D1.6. So you're going to weld a carbon steel to a stainless steel. It usually falls under D1.6.
Yeah.
Most of the time we don't see that caveat in D1.1. It's only been a handful of times in my career I've touched D1.6 out of all the things I've been involved with. And it's one of those ones that if you never pick it up, it's probably not a big deal. It's just,
Yeah. I've actually used D1.6 a lot. I started in my internship. I was working on industrial ovens. A lot of them are in corrosive environments, so usually the structure was always sheet metal, it was always stainless steel. And my very first welding job, I was welding restaurant appliances. So like all the tables, all the curbs, they by code always have to be stainless steel.
Okay.
So we would touch it a little bit. And then I'll jump on the nuclear side. Often the reason you run stainless steel is like you're saying, if you're going to make a reactor, it's going to go hot, you can't get in there to inspect it. If a little bolt is rusting out, 5-10 years later, you might not know. But also boron is commonly used in nuclear reactor water as a neutron moderator, but also it generates boric acid, which rusts
steel.
Yeah, steel, but it won't rust stainless steel. Yeah. So a lot of times they'll do stainless steel liners, things of that nature. To help. Yeah, it's just like a belt and suspenders approach.
Yeah.
Also, I'll say when you start getting into stainless steel welding, I see a lot of kind of general shops. Hey, we know our stuff in steel welding. What's the difference in stainless steel? This is where I think cleanliness practices become even more critical. Corrosion resistance practices. If you're going to spend all the money on 316, 304 stainless steel, then you need to do the actions that are going to prevent it from becoming or to make it corrosion resistant. So no point in using 316 and then hitting it with a steel wire brush and having it start corroding anyways. So I see a lot of people get there of like, well, no, in the muffler shop or whatever, we just welded right through paint. Well, you've seen it before.
I have, yes.
But like, hey, we're working on stainless steel. It's gonna be in the ocean. We need to do the right things to keep this from corroding out. We need to passivate, pick the right filler metals, etc. So where I would always recommend this, again, same thing. Hey, I want to start doing stainless steel. Whether I'm just making a grill table. Again, working on bicycles, something like that. Working around the boat. I want something that won't rust. Okay, well then take the time to actually learn, the additional requirements and clauses for stainless steel welding. And as I've said in other videos, and almost all welding problems are cleanliness problems.
Well, we were talking at dinner the other night about a unique problem you encountered, and I said, "Oh yeah, big problem with liquation cracking, which is one of the cleanliness issues surrounding stainless in general, is that we don't have brass or bronze or copper because those low melting point materials will work their way between the grain boundaries, and the second you heat them up, that's when cracks start. So that's another reason why your stainless shop and your carbon steel shops are usually not one and the same. There's usually segregated areas so that any of those low melting point materials are not coming in contact with your stainless.
Yeah.
Right. So just to prevent that right off the jump.
Yeah, and I'll add in here one of the most common things you see. All your welding equipment down to your gloves, your grinding wheels. If you're grinding on carbon steel and then you go and grind on stainless steel, you're going to embed all that iron into the surface. That iron will start rusting. And then corrosion is kind of one of these, once it starts, it's not going to stop. But if you don't ever have it start, you're good to go.
Yeah.
So I've seen it plenty of times where people are like, what? I'm just using a wire brush or whatnot.
Well, the other one with the wire brush is that, are you using a stainless steel wire brush? Because most of those wire brushes are not a 300 series stainless. So if you've got, they're going to cost you more, but to order this this wire brushes that are actually 300 series stainless, and not just like a martensitic stainless or a ferritic stainless. It's another one.
Yeah.
So double check that, right? So
Yeah, yeah.
there's a lot of those little things that make stainless steel fabrication not as easy as it looks, and it's a it's a lesson you'll never forget.
Yeah.
So
yeah, exactly.
because it'll happen. It's
Yeah,
just, you'll
yeah.
never forget to make the mistake again.
Yeah, and then you're like, you got this beautiful looking thing, and you're like, why are all my welds rusty right
Yep.
now? Like, what happened? Yeah. And just to add on to that, the other one I see a lot is passivation, and I think a lot of people don't understand why are you doing passivation, what it does. Stainless steel gets the whole stainless part because of chrome content. You need at least 12.5% chrome. It will create this passive chrome oxide layer. That way it won't start rusting like carbon steel will. Well, when you weld things, you can do something that you can kind of chromium deplete the area right around the weld or the weld if you overheat it. You can sensitize it. So what you're doing with passivation, you're kind of just acid etching off all that iron, that free iron, leaving only the chromium oxide, kind of giving yourself your best starting point for corrosion resistance.
Let me stop you there, Joel. I think you conflated two issues.
Ooh, I've done that before.
So you're mixing up passivation and carbide precipitation.
Correct. Yes, these are two separate issues.
So carbide precipitation is depletion of chromium in the grain boundaries after a weld.
Correct.
Passivation is you're just taking an acid of some sort, depending on whether it be citric acid or nitric acid, and stripping a new layer, exposing that chromium to oxygen to give you that passive layer. Okay?
Correct.
And you can do that on the gross sections. You'll see in a lot of the pipe shops I've been to around the world where they've got a vat of just like a green liquid, and they'll just dump the pipe in there, and it eats it away, and then they go sit in the corner for 48 hours, let that new layer.
Yeah.
Which is not the same as carbide precipitation.
You are absolutely correct.
The affected zone.
And they do have different root causes there. Also, that citric acid is really like orange juice concentrate.
Yeah, the citric acid ain't worth even bothering with. It won't work.
I like it because it smells really good. It always smells like lemonade, and I almost want to drink it.
I'm glad because the nitric acid stuff is really nasty, and when you open the bottle, you're like, whoa, this ain't to be messed with, and it ain't.
Yeah. But the citric acid, it smells like a lemonade stand.
It might smell good, but it don't work at all.
It's not as aggressive, but it's more environmentally safe. It literally is like a byproduct of like orange juice and lemonade manufacturing. We use it a lot, depending just because of the drain safety, et cetera. It's a little bit easier from an environmental standpoint.
Yeah, I've worked on a couple big projects where we had to passivate all the welds, and we used a gel that was a nitric acid, and then everything that we wiped the welds off with had to go into a special trash can and got taken away to a remediation place.
Yeah.
You can't just throw it in the garbage. That's why a lot of the passivation places that have the large vats of those, getting permits for that in places like America or Canada are not the easiest.
Yeah, especially here in California, which is why we ran citric passivation, because you can neutralize it. It is a lot kind of more inherently safe if something's spilled or whatnot. Not that you should be spilling it, but it's not nearly as bad. It literally is orange juice concentrate. It's an extract from orange juice concentrate. But yeah, that's D1.6. If you're starting to get into stainless steel work, this is a great place to look. But my big caution is if you come from welding steel only and you're wanting to step up stainless steel, go check what the different quality requirements are, especially if we're talking about here around corrosion, around contamination. Some things that are perfectly acceptable in steel will start tripping you up when you go to stainless steel.
Absolutely.
And next code is a code I'll introduce.
Here we go.
So next code up is D17.1. This is the aerospace code here. It covers all major metal groups, or say all metal groups that you would see within aerospace welding. It's going to have specific inspection criteria, fabrication criteria to aerospace. It's known as a high quality code here.
Well, first off, it's technically not a code.
Good call. Explain.
So a code is a legally mandated requirement. that uses the word shall, and that's a requirement. D17.1 is actually a specification that you can invoke or you can not invoke, okay? And part of the reason that, we talk about this is that there's a lot of fabrication of aerospace parts that existed long before 17.1 existed. And 17.1 is kind of an amalgamation of some of the old mill standards and some new stuff. And you're going to have to write in your specification, in your contract, that you're invoking this document, okay? It's not legally mandated. And this, Joel may like it, but this is what leads to some of the shenanigans that I think could be clamped down a little bit more on in the aerospace world to make things a little bit more even, especially when we talk about allowables and we talk about engineering authority, that type of thing, right?
Yeah.
So you're right. It covers all your metal groups that you're going to see. It covers coppers and aluminums and stainlesses and
Titanium.
even some of your steels for tooling.
Yeah, Inconels, your super alloys, yeah.
So, and in the recent edition, the 2024 edition, they've added a clause for human supported space flight. Okay, so I think that that's a great addition, especially coming from someone who worked for a company that had human-rated space vehicles. It was great to see that come to fruition.
How'd those welds work out the other day for you guys?
I wasn't involved in that. Okay, I've not been there for.
I'm gonna edit in a clip right now of what we're referring to, but yes.
I should give you the picture of me standing at the launch pad and seeing what it looks like now.
Oh boy, we're referring to a circuit rocket that just recently rapidly disassembled itself. During a test event.
Well, that'll happen on these big jobs.
Yeah, and on it, all jokes aside, when we start talking about the things, one of the things you're going to start looking for is welding, because you're welding all these liquid oxygen lines, these fuel lines are at high pressure. It's a really high, difficult surface environment.
I hope it wasn't the line, the tanks or the lines running to the pad, because I was involved with that. So I really hope it wasn't that.
At the root cause of that, it was easy to be like, oh man, I hope it come on anything else.
I'm glad that both the company and Kennedy did their due diligence in having safe space for everybody.
Yeah.
And being sure that there was nobody around and nobody was hurt. That's the main thing, is that you can build. The main point of all these codes or standards is that we're doing something so that if Joel buys something here in California, or if I buy something in Canada and it said it's built to D1.1, is that it's the same product, right? So that we know that we're getting that certain quality level, and we don't have to worry about risking your life with it. And that's really what we're talking about, right? And going back to 17.1, the hard part with 17.1 is, especially when we talk allowables, right? Where do you find allowables in 17.1, Joel?
Table 7, I want to say.
There's no allowables in 17.1. It all says engineering authority. Next you're going to tell me it's the MMPDS. And next you're going to tell me it's Marshall Space Flight 3679. The problem is that there's no codified acceptance criteria across the industry for tensile strengths for materials, right? And a unique part about the aerospace industry, and I'll let you tell it, is that depending on what part of the plane you're in or structure, you can have the same material, the same weld, and the allowables are different.
Yeah. So I'll break this down a little bit further here. So 17.1, it's not unique to it, but it does something. It has 3 different classes of weld. You have Class A, which basically states, if this weld breaks, it's going to be immediate threat to the vehicle. Think that I always say the welds that keep the wings on the airplane. You have a Class B saying, hey, this is critical, but not quite. And then you have Class C saying this is not a critical weld. I was going to say, think of the nameplate welded onto the side of the airplane. Brackets. Brackets, think of the nature, the luggage bins. So within that, 17.1 gives the designated engineering authority, or a DER here. It gives them more control over what they're doing. They also have to do more work. When we talk about tensils, the reason they don't have them in there is because they might heat treat aluminum or titanium. They might be ending up for, we only want the very highest quality heat treat, and then we want to ensure that our welds aren't affecting that heat treat. that would be different than someone making, a baggage device or whatever, a bracket for a seat, that same material but doesn't have those same requirements. So it requires you to do a lot more, and it requires the engineering authority to have a lot more input on it, but also gives them more optionality to pick what they're doing. The reason I say it's a high quality code is that it basically assumes and demands 100% volumetric inspection for every single piece if you're doing Class A. Class C, not the case, but Class A, 100% volumetric inspection. So this gets you away from the shenanigans that in other codes are like, hey, I was talking about in D1.1, you don't have to do this.
Yeah, and that's the kind of the peculiarity where we talked earlier is that in the newest edition, the 2024 edition of 17.1, where to run a PQR, you do VT, PT, and RT. No tensils, no bends, no hardness, no CVNs, no corrosion, no anything. But if you're running Class A in production, you're getting 100% RT. Okay, so that's not very frequent in the ASME world where we're doing 100% RT. And so on the front end, qualifying procedures in 17.1 is really cake. It's really easy. But your welders are got to be really good. So this is where the conversation starts, where it's not that other welders are bad, but when you do volumetric inspection of every single weld and those tolerances are really small, that those folks have to be very skilled.
Correct,
right? And
correct.
so that's where, on the front end in D17.1, where your engineering authority of your company, and this is why we see very few large aerospace companies, because startups don't have the amount of money to run these allowable campaigns to know what some esoteric copper alloy is that they're going to use if it's not in the MMPDS or some other source. And these large aerospace companies aren't going to just voluntarily share all that information that they've been building for 80 years and spend millions of dollars on to give to a code that's going to be a law, right? So that's one of those ones where I think, at least me personally, I would love to see it be a code where it's a legal mandate, but I don't see that being likely.
No,
just because you're going to tell a large aerospace company that what they've been doing for 50 years is not enough or too little, and then you still have NADCAP or special audits, so the value might not, probably not there.
And having spent a lot of my career in the aerospace industry, if you're working for all these big the primes, they call them, the Boeings of the world, they have entire welding engineering departments. They have a lot of, historical information, precedent. They'll add their own sections and clauses to the codes saying, we have 17.1, but we also have these special clauses. Even within that, if you're doing this, there's these extra steps, extra tests, extra qualification requirements that are going to be in these codes to meet it. I would say overall, it demands, compared to D1.1, it demands a lot more attention to quality, a lot more of a prove it mentality. You can't really hide from the X-ray. I think that's why a lot of people think it's tough, or X-ray, they call it X-ray quality welding, is because any little crack, any little tungsten inclusion, you're going to see it. Other codes, you might not see it, and frankly, it might not be as big of an issue. But when you're talking about trying to get things as light as possible, but have them be as strong as possible, I mean, we're literally talking about rockets here. The difference in a couple thousandths in thickness or a thousandths crack can be the difference between a successful launch and the rocket quite literally exploding. So all those procedures and things are written there for a reason, and it's to help prevent those. It cannot be 100% perfect, but it sets up a bigger precedence of you got to be a skilled welder, you got to have your procedures dialed in here. A lot more clauses are going to have to fall on the quality side, and a lot more of a prove it mentality, and just tracking more information.
Yeah, and when you go from like an ASME world or a D1.1 shop, if they have NDE, it's going to be outsourced. They're going to have somebody come in and do it every now and again. In the heavy production shops, they'll have their own, but for most medium-sized shops, you're going to have outsourced NDE. Pretty much every aerospace shop that I've worked in, even back to my welding days, they had an internal NDE department.
Yeah.
Everything got some form of NDE. So they were doing too much of it to send it out. Like they're just,
Yeah.
the volume is so much more than what you see for everywhere else. And that's why as a welder, being an aerospace welder comes with a certain degree of pedigree.
Yeah, and the great ones I've worked with, they'll want to work with you. They'll want to see the actual X-rays themselves. Hey, where was that defect? Let's game plan on how we can get rid of it. My role as a welding engineer in aerospace was always make the job easier for the welders, because some of these parts were really difficult. At one place we had amazing welders, and even of a roster of 200 plus welders, some joints, some particular pieces, we'd only have 1, 2, 3 people who could weld it. Yeah. And it wasn't worth it to try to give it to someone else when the cost of failure was scrapping out a $100,000 part. So you're going to take all the extra precaution and care to ensure you're going to get this weld done. We're talking about welding inside a bubble chamber, so there's no oxygen for titanium. Special fixtures, very complex heat treat schedules and procedures. And again, a prove it mentality. The one thing I'll mention, I don't want to get spent all day here, is filler wire control. So in most other codes, you have to have filler wire control. In aerospace, it's considered very essential. You have to prove every single piece of filler metal and every single weld. And you don't just prove it saying, yeah, I welded with 304. You said, I have to record the lot number, the serial code of that welding wire for that joint. And I've been in situations where 5, 6, 7 years later, you're required to keep documents between 7 and 12 years. 5, 6, 7 years later, there will be some type of field failure, and the authority will basically come in and saying, okay, back in 2016, show me on Tuesday at 3 p.m. who was welding this. Show me what weld wire there was. Show me the chemistry of their weld wire. Show me the welder qualification. Show me the welding procedure. We need to go back and kind of do basically a deep dive, and we're going to confirm that everything was correct. And if it wasn't correct, there's going to be issues. Yeah. And that's, that's kind of the bar set in 17.1. Why I like it, it is a shorter spec. If people are starting to get into a higher quality weld, or just kind of want to understand it, it's not too hard to digest. It's under 200-300 pages, and a lot of the back are kind of pre-qualified joints. Or
if reading's hard for you, 17.1's for you.
There you go. Maybe reading's hard for me, but I like it. And whenever I'm teaching welders, new inspectors, just kind of the philosophy, because it's more condensed, it's easier to say, hey, go look in 17.1. What does it tell you about cleanliness? What does it tell you about essential variables? Just because it's a little bit more condensed in one place. So back in my CWI days, you could qualify in on 17.1, and that was one of the tricks, because it is much shorter.
You can still do that.
Yeah. I don't want to say that because I haven't done it in so long. But that was and I knew it so well because it is basically hammered in aerospace. You're going to run into it. And usually it's kind of, you start there and then you add more things on top of it.
Well, and that's, most of the primes have an overlay spec where they've got an overlay on top of 17.1. And then the subcontractors are going to have quals and procedures of 17.1 and then work to the overlay specification, right? Yeah. A lot of the primes have their own specifications, right? That's pretty much, a given if you're going to work for a prime. But all the sub vendors, the tier 2s and tier 3 folks, are going to work to 17.1, right? Yeah. Most of the primes, I would be interested to see a prime undergo a NADCAP audit. I'd be interested to see them run procedures to 17.1 because they don't really have them. They have 80 years of data from all the stuff they've done, right? So
yeah. And actually, that's a really important little side note here. We're talking about audits. There's some major kind of overall quality systems that usually sit on top of welding codes. If you're doing this high quality welding, then the next question is, well, as an organization, prove how are you doing these things in a repeatable and quality manner. It's one thing to say I have a procedure. It's another thing to say I have a procedure, I'm how I'm going to follow the procedure every day. So we start with ISO 9001, which is the most common one. That's just a very general quality code saying, here's a way of organizing your shop. Do you have a procedure for all your major practices? Are you following that? Are people trained to it? Then you go to AS 9100D. This is basically a defense contracting. A lot of people say it's aerospace, but it's defense contracting.
I was going to say, it's not just aerospace.
It's not just aerospace, although aerospace
kind of
adopted it. It takes ISO 9001. It adds more specific quality information and requirements. As one example, if you ever have a quality release, something bad gets to the customer, you have to have a formal process for how do we accept this information back, how do we go do an investigation, how do we get up a solution, and then how do we check that that solution actually worked. You can't just say, oh yeah, shoot, we'll fix that next time.
Yeah, and that's one of the QC guys I worked with at the aerospace company back when I was a welder was like, my work's more important than a doctor. And I says, well, how do you figure that? And he says, well, when a doctor messes up, only one person dies. When I mess up, 300 people die.
Yeah.
So, having that feedback loop between the customer and the engineering department of potentially having something go wrong is vital, right? So it's not about, hey, you guys did something wrong. Audits aren't to catch people red-handed. They're to just confirm that, hey, we're doing this. We gave you these parts. Somebody's going to check that you're really doing that, right?
Yeah.
And that if there is a problem, let's hope it's not loss of life. Let's hope it happened on the ground.
Yeah.
And you can't really pull a plane over and
let's
pop
check
the hood and see what's going on, right?
Exactly.
So,
exactly.
The stakes are a little bit more heightened there.
Yeah, exactly. And then the final code I'll mention here, or quality system, is NADCAP. I'm going to butcher this. It's like North American Defense Contractors
Accreditation Program.
There you go. Look, thank you for saving me on the last two there.
I'm pretty sure.
Yeah, and this is, I say, kind of even above and beyond now AS 9100D. Now the primes, these large defense companies, kind of got together and say, hey, here's some other criteria we want to put in. If you're working on defense contracting, which again is a lot of aerospace, military programs, often you'll have to be NADCAP accredited. They'll have a whole separate auditing body that will come in and saying, are you doing things, in the pursuit of making defense products in the U.S.? So in a lot of aerospace shops, you're going to have all three certifications, just understanding the differences, knowing which ones go where. NADCAP can let you do some things, but AS 9100D won't. And then Boeing will say a different thing.
Yeah.
So it gets quite a lot just managing all these requirements. And welding is one of the areas they hit the hardest.
Well, the nice part about NADCAP, though, is that they provide checklists.
Yes.
That you can go download and you can know exactly what the auditor is going to look for.
Yeah.
Okay, so if, the customers I have that are coming up to NADCAP audits, I always send them a packet over, well, for your specific activity, whether it's spin forming or heat treating or welding, here's the checklist that NADCAP's going to use. You go through this on your own. Go grab somebody from the front office who doesn't know anything on the technical side and have them go run through this checklist.
Yeah.
If they can pass everything that is on that checklist, you're going to be okay.
Yeah.
Right? If you've got to have a bunch of asterisks and have a bunch of technical explanations that somebody who doesn't have that background can't just go through and make that checklist, your audit probably is not going to be as smooth as it could be.
Yeah, as soon as is in the audit, you're saying, well, we don't really need to do that because don't worry, Jim's always been really, it's like, no.
See, what had happened was, see, that's where you get that's when it starts.
Exactly.
That's when it starts.
And also I'll say, from a quality philosophy and standpoint, I actually say the auditors are on your side. I think a lot of people have this kind of twisted view of quality, like it's the fun police, hey, no doing that, we're just here to slow you down. But really, we're here to make sure we have a quality product. I think the auditor is saying, hey, thank you for finding something, this is for something us to fix, not, hey, let's just kind of shuffle around the paperwork, get the illusion of quality as soon as they go, hey, we can go back to normal. Also, people are like, well, this is slowing down. Doing 100% X-ray is expensive, is slow. What I always tell my teams is, this is the product. We're paid to do this. Let's go do the x-rays. Let's bill the customer. They're expecting that. If we're going to make something that's life critical that my family's going to fly on, I want to know that those welds are
Absolutely.
good. So it is part of the product, not like the fun police just saying,
Yeah.
hey, you can't do that, but even though it's better, no, there's a reason.
The auditors are there because their company wants to be, either your company wants to be accredited or their company wants to buy something from you, right? They're not going to bend the rules, but they're also not looking for reasons to disqualify you, right?
Yeah.
Because if you lose your NADCAP certification, that's one less company they can buy from, and that's going to drive up their cost. It's going to mess with their lead times,
Yeah.
right? Like you said, the auditors, again, they're not going to bend the rules. They're not going to go, well, you gave me a great explanation.
Well, you know what? John is a good welder. You know what? We don't need to qualify him.
That's not going to be enough. But they're really looking out for both parties where, hey, you guys said you're doing this. I'm here to check that you're doing this.
Yeah.
And if you are, we're okay. You know what I mean? And the problem with the NADCAP audit is that there's so many things that go into it. You can't, like you said, shuffle a bunch of papers around and make it look like you're doing this stuff when people aren't there. There's just too much to do.
Yeah.
You're not going to be able to fake that much of that amount of work. It's just not going to, being dinged for some document not being up to date or not having access to the latest revision or something. That's a small item, right? They're not going to disqualify you for that.
Exactly.
Right? But just saying, hey, John's really good. I hired him and he's done great.
Yeah, or trying to go back to a bunch of documents and quickly change the revenue. It's like, no, don't do that. If ever, just like, yep, that's an issue. Let's go improve it. As soon as you start getting really defensive, well, you see, oh, that was a deprecate. No. Hey, man, thanks for finding that. Great, let's fix it. And as you were saying before, like, I think these quality systems also seem scary when you're not used to them, but the answers are always in the book. Like, they're not trying to hit you with a gotcha question and like, well, what about that? It's all there in the code. It's all there in the books. So, like, it's an open book test that you know what you're going to be tested on.
If the auditor asks you a question that you don't know, it could be outside your scope. Just say, hey, purchasing, I'm a welder. Purchasing is the one who takes care of that. I'd have to ask them, or that's outside my scope, right? Answering that way doesn't come up as a bad audit. It's maybe that isn't your job. Maybe that isn't, you know what I mean? The individual doing the audit has a list of questions to ask.
Yeah.
They don't necessarily know if you're Joel the welder or Joel the purchasing agent or Joel the quality manager. They don't know any of that, right? They just...
And a small shop, it could be all of those
It could be, but for the bigger places, it's like, I've been through a bunch of ISO audits and, hey, is your tape measure calibrated? Yes. How do you know that? Well, we got a calibrator that I'm supposed to check every week, and I got to sign on the sheet, and here's my signature.
Yep.
Right?
Yeah. And they're all just a collection of best practices to how to get quality work. Yeah, I do a lot of audit work. I've come in a lot of times when people have failed or are failing audits, and I'm there to say, okay, great, this is okay. Let's find the way. The only thing I can't fix is bad culture. People don't think it's important or just think it's like something that you're trying to navigate around. That's not a quality mindset, and that is what you're trying to prevent for things that are life critical. We could talk all day about quality, though. I think we have one more code we want to talk about.
Oh, yeah, the best one?
Save the best for last.
Save the best
then
for
we
last.
should have done 17.1 last.
No, we should have done that first. Just don't dump it in the garbage.
All right. What is the best code?
Well, I'm going to say it's the ASME ecosystem.
Okay.
And I say ecosystem because you've got reference codes and you've got construction codes. And in those, pretty much all your answers are there, right? There's not a lot of room. Engineering authority, like it exists in D1.1, D1.6, 17.1, doesn't really exist in the same space in the ASME ecosystem is. That you can write to the code committee and ask them questions, and they'll say yes or no. But pretty much there's enough information between either the reference code or your code of construction where all your materials are in section 2. All of your welding's in section 9. depends on, are you building a pipeline? Are you building a power plant? Are you building a hydrogen storage facility? Was going to lead you to what those are, right? So the nice part about the ASME ecosystem, at least for me, is that everything's already in there, right? I don't have to think as much about 17.1 of what my allowables are. It tells me what my minimum tensile is. I want to know thermal conductivity. I go to section D part, or section 2 part D, and it's in there, okay? Now, there's always cases where there are unclassified materials that aren't in the code, and you've got to develop those allowables, right? But that's for really corner case situations. It's going to tell you how to qualify welders via process. It's going to tell you how to perform NDE. So it's going to give you your quality levels, your acceptance criteria, all that inside your construction code. Okay, so I don't have to go, it's not like D1.1 where I go, well, I know I'm going to have to do at least 100% visual, but maybe Joel's company wants 50% RT on CJPs. Okay?
Complete joint penetration, by the way, CJP.
But B31.3 is process pipe. If we're going to do a severe cyclic job, there's 100% RT. There's only been a handful of 100% RT jobs I've ever been on in my career. Most of them are normal where you get 5% RT, 10% RT, 20% RT. Okay, but it's all lined out, and it's going to tell you, ASME Section 5 is going to tell you exactly how to perform that NDE, and then go back to the construction code for what the acceptance criteria is. 17.1 for RT is going to tell you, hey, perform in accordance with ASTM Echo 1742. Okay, so I got to go buy another ASTM document from them. And then that's got three other documents that it references. Okay, ASME, it's all right there. Yeah, it's a million pages, but it's going to tell you exactly how many IQIs they want, what the density is supposed to be, and how exactly to perform that shot. Okay, so that level for all the ASME work is pretty much the same, right? Where in the aerospace world, depending on how long you've been in the game and how much money you got to spend can really determine what your footing is. Not the same way in ASME, right? So we see that. I would love to see more radiography in production rather than on PQRs, but that's up to whatever code that is. And depending on, if we're talking unfired pressure vessels, Section 8, Division 1, you can have varying quality levels depending on how much RT you have. So it's a lot kind of similar to the quality levels in 17.1. The lines of demarcation are not as wide. But again, depending on what these items are and what they're doing, you've got a really good guide, right? It gives you a soup to nuts everything, where 17.1, it's this thick, and half of the verbiage just says, look at your engineering authority. So if you don't have a really robust engineering authority that has all that information.
Yeah. Like if you're a startup and...
If you're a startup,
and
which you've done before,
and
right?
you are the engineering authority,
right?
And now you're a small design team, you're saying, oh shoot, we're not great at welding, welding design.
Yeah, so all the stuff it's the same calculations, it's the same material allowables, right? So I know that if I buy a pressure vessel that is a Section 8 Div 1 stamped vessel from anywhere in the world, that it's going to be using the same exact information.
Yeah.
And that quality level is standard wherever you are.
And real quick, what industries do you see that use ASME codes?
We're going to see refineries. We're going to see power plants. We're going to see all kinds of chemical plants, petrochem. I worked on a desalination plant that was all ASME. So anything that's basically pressure containing. ASME really cares about, at least when we talk about most of these codes, is does it hold the pressure, does it not hold the pressure? We got Section 3 that handles NPVs, nuclear pressure vessels. So all of your nuclear pressure vessels are built in accordance with this code. Okay,
Not
so
all that's a separate. The military ones I worked on, we worked to our own codes, but we fell back to those codes. Basically said if we don't cover it, go back to ASME, and they're going to cover it as well.
But that's the nice part is, okay, you want to build an SMR. There's tasks and subcommittees for the ASME code that are already doing that, right?
Yeah.
So that You can lower your barrier entry for materials. You don't have to use crazy alloys that haven't been developed before. Well, you don't have to go out, you know that I should be seeing on all my pieces of RT film that there should be an IQI somewhere on each piece of film, right? You know that those are the basics, right, that you're going to get every single time, right? And you can look it up in a book, right? So I know that a lot of people joke, say what ASME stands for what?
Actually, I don't know.
Always, sometimes, maybe, except, right? But that's not really the case, right? Is that, when you go back to D1.1, the big joke is that the big tables giveth and the little notes taketh away, right? Yeah. Where it says, hey, you can do something, and then at the bottom it says, no, you can't really do that, right? ASME, I know the joke is always, always, sometimes, maybe, except, but what they're trying to do is not have you do extraneous testing, not have you doing a bunch of stuff that's not value added, right? What they're trying to do is say, hey, these are the things that matter, right? Every time we want to do these things. And it's based off of when a pressure vessel explodes, people get hurt, right? Yeah. And we drive down the road next to pressure vessels, we walk next to them, and we don't know that they're there, but they are, right? And so we've got a lot of industries that rely on this, right? So I love being able to look up and go, hey, this is what it's supposed to be, right? And there's no real discussion about, hey, well, it could be this, or hey, I could change that, or hey, it's class B, or class,
or the engineer can change his mind.
Or the engineer, or the individual I'm arguing with went to the engineering authority and pled his or her case and said, well, the EA thinks that we should do it this way and this will help us, right? Yeah. These are the rules, you can follow them, you can either make it or you can't. Yeah. That middle ground of, well, maybe, doesn't really exist in ASME, right? So that's, to me, I know everybody's scared of it because, you add all those code books, it's like 3,000 pages, there's a ton of them, right? But all the information that you really need is in there. You don't need
5 other ASTM specs.
5 other specifications and open a whole bunch of other documents, and you don't have to write, a whole bunch of other paperwork, right? It's all right there.
There you go.
Right? So I understand that it's not, rockets, it's not aerospace, but
we don't all get to be the pleasure to work on those.
Well, so, I mean, to me, that's the value of it, is that, and even if you don't, I know a lot of people, in my consulting work was like, well, where do I start? And that's, just because you're not working in a code shop or using a code doesn't mean you can't refer to 17.1 or D1.1 to see how much cracking is allowed in something. Yeah. Right? The point here is that, if you kind of follow one of them, quality level is probably going to come up in your shop. Yeah. Right? You're going to have some sort of rules, right? The whole point here is that we don't have premature failures. We don't have loss of life, right? And for my money, ASME is the most straightforward out of all of them.
There you go.
And I know that you look at it and it's like, oh my God, there's all these pages and it's so long and it's dry. Yeah, it's supposed to be dry because it's trying not to have people get killed. That's the whole point, right? So I know that you're not a big fan of ASME. You're the 17.1 guy, but your background's aerospace.
Is in aerospace, and that's what we use. So that's what I grew up on. Was in 17.1.
I get it.
I've dabbled in ASME, especially when we're doing like pressure vessels, is where it comes up, at least in the industries I was in. And I think to me the whole point of this video is there's not like one code necessarily that's best at everything. Except ASME. Or they're designed for different industries. What is allowable in building a bridge is not the same as building the welds that keep the wings on a 737. They have a different quality of care. If you try to do that on a bridge, the cost would go up 10 times. And I think you're mentioning here, the codes are relatively accessible, as in they're not that expensive. Even if you're a non-code shop and you're saying, well, I don't want to spend $200 on a book that could, prevent me from scrapping 1 or 2 pieces that cost $10,000, like, go spend the $200. You don't have to follow everything, but they are a collection of best practices on how to increase the quality of welds, or how to say, I have some assurance that my weld meets a certain level of quality. So even for non-code shops, I always encourage welders, just pick them up. Read 15 minutes a day. You'll get through it. Don't try to sit there and read 1,000 pages, but just read 15 minutes a day, and you'll make it front and back through the code, and then you'll start understanding. Oh, okay. Now I get, what inspection criteria are. Now I know where to go look. Even if I'm not doing to a code, I'll still often refer to them and just say, hey, yeah, what is the cracking allowance in 17.1? It's a pretty high quality one. It would be a good place for me to go on any, TIG welding process to look at it. Like, well, if they're not accepting it, well, why should I accept it? Or, hey, this is kind of borderline. If this is good enough for aerospace class A, it's probably good enough for your bicycle as well. So with that, just running through the codes one more time here. D1.1. It's
structural steel.
There you go.
Big, dumb, and heavy.
Yep.
Just how I like that.
D1.2.
Structural aluminum.
There you
So
go.
we're building some sort of structure.
Yeah, or you're building a fishing boat.
Now, I've done a bunch of fishing boats to D1.2. They happen to have guys with night vision and rifles that happen to go on a fishing boat. But
Hey, there you go.
allegedly.
Yeah, a different type of fishing. D1.6.
This is all structural stainless. So we're going to have some sort of structure. It needs to have a higher corrosion resistance, and hopefully whenever we can put it somewhere and never have to look at it again.
There you go. D17.1, I'm going to answer this one.
Go ahead.
Aerospace, if you're looking to weld Inconels, titaniums, looking to do things that are lightweight and high quality, D17.1 is where you're going to start, and where most of the customers in that space are going to force you to go look.
True story.
And finally, ASME.
Basketball, right? Pressure containing, right? Let's hold some pressure and call it a day.
There you go. There you go. Well, hey, that's been a probably too long overview of the different codes. Really just wanted to have this as an overview, kind of starting, oftentimes when I'm talking to manufacturing engineers, shop owners, you get that big juicy contract dangled in front of you, and all says, oh yeah, but by the way, make sure you go meet D1.1, you go meet D17.1, and all of a sudden it goes from, oh, this is great, to, oh no, I'm nervous here, what do I do? Just go read them, go start. Like, these things aren't, they're not designed to trick you. They're designed to give you a set of best practices, and if you follow them, they're designed to bring up the quality of your welding. And you'll almost never say, man, I wish I had a lower quality weld.
Yeah, exactly.
So
I wish this thing broke sooner.
Yeah, I wish this thing had more cracks in it. So just go read them there, start, and if not, you can call up one of us. Logan, where can they find you?
You can email me or my website.
All right, we'll put that in the description.
Email.
Me, you know where to find me. You can find me on Donut Tools. I do consult, but mostly as a favor to customers, saying, hey, let me help you out. When I need heavy consulting work, heavy code interpretation work, I actually go to Logan. Logan's who helps me out answer these questions.
When I have tube stuff, Joel helps me out.
There you
when
go.
he has code stuff, he comes to me.
And actually, that's a kind of good point. Welding is so big. I've never met a welding engineer who's like, oh, I'm versed in every code. Also say, well, give me time, I'll learn it.
Yeah.
But if you start quizzing me on 1.2 right now, I'd say, I know there's aluminum in it, but yeah, I haven't read that code probably 10, 15 years, and I don't have a deep bench of welding experience, or excuse me, aluminum welding experience. And in aerospace, we stay away from it because aluminum, all the high quality grades of aluminum naturally want to form cracks and want to form pores, which make them harder to qualify. So
hard open arc weld, at least.
Yeah. So just don't weld them. I'd rather just.
Yeah. What's the old joke? What's the best weld you got to make?
No
weld at all.
Yeah, and
that's the truth.
Oftentimes, as welding engineers, you're kind of like, my biggest advice to you is just bolt this thing right now. Go glue it. If you don't need to weld it, don't weld it.
Don't add more weld. Just.
Yeah. So I think sometimes I've joked, I'm like my first consulting day is just don't weld this. That's it. Problem solved.
I've been down that road.
Anyways, I hope this was helpful here. I'm Joel Ifill, the Tube Dude. You are Logan.
I'm Logan, the code guy.
There you go. Thanks for tuning in. If this is helpful for you, have any questions, leave them in the comments or reach out to us. You know where to find us. Signing off.
See ya.
Bye.